Okay, good morning. This is Professor David J. Reyes. Okay, my topic for this session will be you should be lesson number 4 for alternating current circuit. Okay, let's proceed. This is lesson number 4. Alternating current circuit, lesson number 4. The title of the topic is we are still with impedance because impedance was actually the foundation of alternating current circuit. Without knowing how impedance works in alternating current circuit, okay, there will be a problem. So our next topic will be impedance conversion. The conversion of impedance. It will be from rectangular to polar and vice versa. The first one will be from rectangular to polar and polar to rectangular. So for those of you who are taking up electrical engineering, okay, try to concentrate on this one because without knowing this conversion, you will not pass your board exams. Okay. This is necessary in the study of alternating current circuits. That's the conversion of impedance. That is from rectangular to polar or polar to rectangular. There are so many variations of the so-called rectangular form and polar form, but for this lecture here or session, I will be presenting two. Okay? Okay, let's proceed with example number 1. The designation of impedance is actually capital letter Z. And we are given 3 plus G4. Okay? 3 plus G4. So as you can see it, the second number is preceded by the J sign. So this is actually a complex number. Complex. Okay? Instead of the letter I, which is being used in the study of algebra and the study of alternating current to what you call this separate designation from the imaginary under the study of algebra. Under the study of alternating current circuit, we represent the imaginary part to be preceded by a J sign. So actually impedance is a complex number. Okay? Do not treat this complex number as just simply real numbers. It's just like a 3 times 3, which is 9. But what you call this, in the study of alternating current circuit, if we are multiplying magnitudes and it involves the J and a certain angle, okay, the method of solution is actually different. Okay? So what is given, for example, number 1 is Z equal to 3 plus G4. The problem is asking what is Z in polar form. Polar form meaning the problem is asking for the magnitude and direction of the impedance. So meaning to say, if we are to express this what you call this impedance, which is in rectangular form to polar form, we should specify the magnitude and a certain angle theta. And this certain angle theta could either be plus or minus. Okay? If H is plus, okay, it's an inductive load. Okay? Meaning the reactance is a motor load or a coil or a ballast. If it is minus, the load, the imaginary part is actually a capacitor or a synchronous motor that is overexcited. Okay, let's try to bring out the solution. Z is equal to 3 plus G4. Okay? It's a complex number. So the first one is the real part. The one which is preceded by the J sign is actually the imaginary part. And if we try to bring out the vector diagram of this one, because actually impedance is a vector quantity, it got a magnitude in a certain angle theta, meaning a direction. And the direction, it could either be plus or minus. Okay, if we try to figure out or bring out the vector diagram of the Z, which is 3 plus G4, the real part is 3, the horizontal part. And the vertical part, since this is plus, it should go up. Right? So the direction of this arrow here is upward, and the designation is J4. Okay? Why J? All vertical component of an impedance represents the imaginary part. Okay? So actually, we are given a right triangle. This is the 90-degree angle. This is 3, and this is 4. Okay? And we are asked to compute for the value of Z. Oh, that's an easy thing for us to do, because in the study of trigonometry, if we are given the two sides of a right triangle, we could compute for the hypotenuse by using the Pythagorean theorem. So actually, in the computation of the value of Z, or just the magnitude, the absolute value of Z, we could either use 3 solutions actually. We use the Pythagorean theorem. So solution number 1 for the computation of Z. Okay, we bypass this one first. Okay, the absolute value of Z will be the square root of 3 squared plus the square of 4. And the squaring of the value of this don't include the J. Okay, the designation J is just that this portion here represents the imaginary part. But if we are considering the right triangle, don't include the J. So this will be a 4 quantity square. That will be 9 plus 16, square root of 25. So the unknown magnitude of the impedance is actually 5. The unit of this should be ohms. Okay? Second solution for the magnitude of the impedance. Take the cosine of this angle here. Take the cosine of this. Okay? But before that, let's try to compute for the value of theta. Okay. For the value of theta, for the meantime, we do not know. But since this side here is 4 and this side is 3, and the relation of 4 and 3 is either cotangent or tangent, so if we try to compute for tangent of theta, okay, the direction of the unknown impedance, it will be the ratio 4 over 3. Taking the arctangent of both sides, the arctangent of tangent of theta will be theta, and the arctangent of the right hand side will be the arctangent of 4 over 3. And theta will be the arctangent of 1.33, and theta is actually 53.13 degrees. So the unknown direction of the impedance is 53.13 degrees. Meaning to say, if this is 4 and this is 3, this will be 53.13 degrees. So as a second solution to the magnitude, okay, before I will give the final answer, take the cosine of 53.13 degrees. The cosine of this will be adjacent side over hypotenuse, so that will be 3 over the absolute value of Z. Computing for this, okay, the absolute value of Z will be 3. We will divide that by cosine of 53.13 degrees. Algebraic manipulation. 3 over 0.6, and 3 over 0.6 will be 5 ohms. Because if you try to multiply this by 10, and you multiply this by 10, that will be equal to 30 over 6, and 30 over 6 is 5. So this is 5. Okay? Third solution for the magnitude. Take the sine of the angle. The sine is actually the opposite side over the hypotenuse. So sine of 53.13 degrees will be 4 over the absolute value of Z. And the absolute value of Z will be 4. We divide this by, equals, place it. This is 1 over sine of 53.13 degrees. Okay, then the top portion will be multiplied by the absolute value of z. Okay, so the left hand side multiplied by this one cancel with this. What remains will be the absolute value of z. For the right hand side, 4 all over sine of 53.13 degrees. Okay, what's next? If we try to multiply 4 over absolute value, this absolute value cancel with this. So what remains on the right will be 4 over sine of 53.13, and that will be 4 over 0.8. Or you just multiply this by 10 over 10, so that will be 40 over 8, and that will still be 5. So actually, in the computation of the magnitude of the unknown impedance, we could present resolutions. So if you are in the board exams, it's up to you what solution you will be using. Because in here, I presented 3 solutions, so it's up to you to choose your solution. Okay? Therefore now, the given impedance, which is 3 plus G4, the equivalent of this in polar form should be pi, okay, angle 53.13 degrees, and the unit is ohms. Okay, I place it here. This 5 here is the magnitude, and this 53.13 degrees here is the direction. That will be our answer. Okay. You will be using a scientific calculator for this one. Because in the computation of this, 3 over cosine, you don't have to place this. Okay? If you're on the board exam, or you just place immediately the value of this by performing this operation on your calculator. Even the Pythagorean theorem, you don't have to place it like this. You just place it the square root of 3 square plus 4 square. You just place immediately to be equal to 5. Okay? But if the examiner is looking for the complete solution, this should be the complete solution. But if you are expediting your solution, okay, and you're rushing to get for the final answer, you operate this on your calculator, and actually immediately you could get 5. Even the second solution, 3 over cosine of 53.13 degrees, it's easy, it will be 5. Okay, 3 over, you place a quantity here, display the 53.13, take the cosine, close quantity, what will come out? It will be 5. Okay, so it's just a matter of using your calculator if you are in the board exams. But I am telling you, without knowing this topic here, you will not pass the board exam. Okay, example number 2. This is inductive. Why inductive? Because the angle is positive. Okay? It is upward. Meaning the load is, the inductive part of the load is actually a motor load, a coil, or a ballast. Okay? Okay, example number 2. We are given an impedance. Okay? This is in polar form because we are given the magnitude and the angle is 36.9 degrees and the unit is ohms. And the problem is asking for the value of Z in rectangular form. Okay? So meaning to say, the problem is asking for the real part plus J imaginary part. So we must have to specify the real part and the imaginary part. Okay? It's easy. To bring out the real part and the imaginary part, try to draw your, what you call this, impedance. Because impedance is a vector quantity. It has a magnitude and direction. So if we try to bring out the vector diagram, this is the x-axis, the 0 degree line. This is the 90 degree line. This is the 0 degree line. It says here the magnitude is 10 units or 10 ohms. And the angle is 36.9. It is plus. Okay? So this angle here measured counterclockwise should be 36.9 degrees. So we are given this magnitude here and we are given this angle. And to bring out the rectangular equivalent, okay, we must have to specify the so-called real part, this portion here, plus this portion. For sure, this exowheel here is a coil, maybe or a motor, or a ballast, right? So, it's an easy matter now to bring out the component of this in terms of the rectangular form. Use your knowledge of trigonometry. That's why trigonometry is actually very important in the study of electrical engineering. Take the cosine first. Cosine of this angle here will be R over 10 ohms. So it will be R over 10. Okay, this is algebraic manipulation. This is, we will multiply all terms by 10. This cancels. R now will be 10 times cosine 36.9. This is 10 times 0.8. R will be 10 ohms. So the real part, okay, is 8 ohms. Meaning to say, maybe all the lighting loads has a resistance of 8 ohms. Okay? Take the sine of this angle. The sine of this angle will be opposite over hypotenuse. Okay? It will be sine of 36.9, that will be x over L over 10. Don't carry the J. J only represents that this portion here is actually imaginary part. Okay? Just take x over L. It should be x over L over 10. And if we try to multiply this by 10, okay, this cancels. XL now will be 10 times sine of 36.9. So this will be 10 times 0.6, or XL will be equal to 6 ohms. So the given impedance, which has a magnitude of 10 ohms, angle 36.9 degrees, it is plus, right? It is plus. It's in the first quadrant. Okay? The rectangular equivalent of this should be, the real part will be A plus J 6 ohms. Okay? Place the J sign here, meaning this, what you call this, rectangular form is a complex number. Okay? It's a complex number. It is A plus G6. You cannot say just 8 plus 6. No, it is not. Because without the G sign, this 6 here is considered to be a real part. But if we put the G here, okay, it is understood that the second part is actually an imaginary part. Therefore, the equivalent of 10 angle 36.9 degrees now will be 8 plus J6 ohms. Okay? So this 8 here is the real part, and this J6 here, including the J, is the imaginary part. Oh, that will be our answer. Okay, that's it, guys. That's the way how to convert an impedance from polar to rectangular, or from rectangular to polar. Okay? Try to memorize this, because till we die, this procedure on how to convert impedance will not change. Okay, that is from rectangular to polar, or polar to rectangular. I am telling you, without knowing this, you will not pass the board exams, because the foundation of alternating current circuit is actually the conversion of polar to rectangular, or rectangular to polar, or polar to rectangular. Without knowing this, you will not pass the board exams. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.